Hi, everyone. My name is William Carter. I'm the CTO of the XX Network, and I'm here with our CEO, David Chaum, to talk a little bit about how payments have been evolving over the last few decades as we've moved from a primarily cash-based society to having digital payments that are facilitated by banks to cryptocurrency, and even more recently, some decentralized finance. So we're going to take this opportunity today to take a step back from the DApp and the second layer hype to revisit the core primitives of kind of what makes a good payment, as that's really what the basis for the blockchain ecosystem has traditionally been. So we'll talk a little bit about what the motivation for this evolution was and how the characteristics of a payment have kind of changed over time. And then finally, we're going to talk about how what we're doing at the XX network is really critical to the continued growth of the cryptocurrency space. Now, David Chaum here, for those of you who aren't familiar, is an expert in payment technology, having really invented electronic cash. He sent the first digital payment over the internet, as well as discovered much of the cryptography that is used in cryptocurrency and also in other areas where privacy and security are critical, like electronic voting and communications. So today he's leading our team in developing the next generation of layer one blockchain protocols at XX Network. And I'll let him speak a little bit more about his background and what we're doing here.
Oh, thanks, Will. It's great to be here, and I guess John Tan from the Global Blockchain Eco Conference invited us to appear here. Well, I guess in part because, yes, as Will said, I did invent electronic cash. In fact, so that is originally in '82. I published a paper at a conference that I organized. I wasn't the program chairman, but at that time, the US government said they would put people in jail for organizing conferences on cryptography. But being a graduate student at Berkeley in computer science and realizing how important cryptography is for the upcoming digital world back then, the early '80s, I decided to just organize a conference on cryptography, even though it might have meant that I, would be spending the rest of my life in jail. And because what I wanted to do was set cryptography free. I thought that was a very important thing, and I launched the International Association for Cryptologic Research at that event, and I presented eCash, which was the first digital bearer instrument, a number that was worth money. And as Will mentioned, I made the first eCash payment. It was turned out probably the first internet payment. It was from the first World Wide Web conference in Geneva, where I was giving the first keynote, one of two. Tim Berners-Lee was the second keynote, the only other one. And I made the first eCash payment from Geneva to Amsterdam to my company then. And it was there was a little press release issued, and it was widely reported globally. And it caught people's interest because it was a real breakthrough. It was the first number that was worth money. It was a digital bearer instrument, and it had a privacy feature to it as well. And my dissertation at Berkeley had been about blockchain, so that was well before most of anything you've heard about. That was appeared in '82, and you can see that on my website at chaum.com if you'd like to read it. In any case, then in the mid '90s, after we made that first payment, we launched Cyberbucks, which was kind of like Bitcoin. It was just a freestanding currency. We capped the total amount. Anyone who set up a shop, we would airdrop them 100 of these Cyberbucks. And then we also helped like Deutsche Bank, which was the largest bank in Europe at the time, and then banks in Australia, the US, and so forth, issue national currency denominated eCash. And this was available in quite a number of currencies, including Deutschmarks in those days from Deutsche Bank, and Australian dollars, US dollars, and so forth. So that was the original form of electronic money. Is sort of, I call that Bitcoin zero. And then, of course, when Bitcoin 1 happened, made a lot of people a lot of money, and it was, I think, a world-changing thing. So it's a huge, big deal. It's changed everything. And now, what we are doing at XX Network is we are creating what you might want to call Bitcoin 2. And it's a far superior infrastructure for distributed finance and for electronic payments in a number of ways. And it's starting to run in beta and alpha. And I can tell you a little bit more about it later, but it's actually targeted at personal mobile. So it's a quantum resistant, very high throughput, low latency, ultra secure payment system that provides proof of finality that can be easily checked on smartphones. And so we're very much oriented towards the mobile users and providing payments infrastructure that it's almost like a white labeled product. The interfaces are public, and so it's really intended to be a kind of backbone for all kinds of electronic commerce and distributed finance and so forth. So let me turn it back over to Will to tell you a little bit about how our technology differs.
Yeah, so first I want to touch on the challenge that you mentioned, making kind of blockchain as we know it today work on mobile phones, because that's really kind of emblematic of just how far payment technology has come. I'm just old enough to remember when we used to carry cash around, or even had to write a check in order to pay people. So payments have really changed a great deal just in my life in the last 30 years. To become more convenient and frictionless. And for the most part, this has been kind of like a massive catalyst of economic growth. It's enabled a new generation of investment, lending, e-commerce. And I can't help but wonder, and David, as someone who's been involved in this evolution of payment technology, maybe you can answer this. Have we lost anything along the way in the move from physical currency to digital currency?
Well, it's an excellent question, and I think, back in the eCash days, I was suggesting to a lot of central banks and government agencies around the world that I was meeting with that any country that would issue a nationally backed electronic currency like eCash might be able to take a real leadership role in what was then certain to be a huge emerging electronic commerce world. Now, one aspect of that was that ultimately, if all paper money transactions were replaced by electronic, then because of the asymmetric privacy in eCash, which we also have now in the XX, that allows the payer to always irrefutably demonstrate who received the funds, it really thwarts any kind of criminal use of a payment system. So it would dramatically reduce corruption and criminal activity because they would have to transact outside of these payment systems. And so the real value, ironically, in electronic payments that I think, maybe we missed in the sense that is that instead of having it be an add-on, optional new thing, it should really be a replacement for paper money and other systems, because that's what gives us the chance to really dramatically improve the, attenuate improper use of payment systems. So what we're trying to do at XX is really create such a good payments infrastructure that someday, hopefully, it'll be all that anyone needs, and we can get rid of these other payment systems which are allowing corruption and criminal activity to, flourish.
Definitely. And I think, everyone that's especially involved in the cryptocurrency space can kind of appreciate that vision and I think that was really what Satoshi probably had in mind with Bitcoin was, replacing the core fundamental infrastructure rather than kind of building on top of what existed. So I think it becomes clear that, in order for this cryptocurrency space to keep growing and evolving, we do need to make sure that the core primitives of a payment, that that core transaction of sending value from one person to the other, that's as secure and robust and fast as possible. And I think when you won the Dijkstra Award in Amsterdam, you actually laid out a set of requirements that a layer one transaction platform should or must meet in order for all these layer two solutions and these D apps that are building on top of it to really reach mainstream adoption. So I was saying, it's critical that this layer one infrastructure in which everyone's using to build these exciting new layer two applications and decentralized apps really meets some core requirements so that we can reach mainstream adoption. And I believe when you gave your keynote address in Amsterdam after receiving the Dijkstra Award, you actually laid out some of the core requirements that layer one transaction platforms must meet for these layer two solutions and applications to reach mainstream adoption. I'm wondering if you could walk us through those three requirements again.
Well, sure. Thanks, Will. Yeah, that was, they only give those awards every 5 years, and I had a whole day of presentations related to some of my other work and various, but I did give like a 1 hour lecture and focus it on our XX technology, and it's probably worth looking at if you want to get deeper understanding and intuition about how it differs and how it really works. In addition to the webinars that we have up and white paper and all that, but the main thing is that when you step back and look at the need for a layer one infrastructure, it's pretty clear that you must have scalability to tens or maybe even hundreds of thousands of transactions a second ultimately. And it's also, I believe, essential for consumers that there's a kind of, what's referred to in payments as finality. In other words, irrevocability and completion of the payment transaction within a few seconds. And ideally, that should be something that the user's smartphone has a proof of. So a signature by some authority that, like the blockchain, that's easily verified by the phone that says that transaction has irrevocably completed successfully in favor of the user. And so that's the latency. And the third and final requirement is, and you might just call it security, but actually, I think, and perhaps it's not that, happy a thing to have to say so, but what we're really talking about here is takedown resistance. Some national adversary or powerful actors might decide that they don't like, a certain chain, and I don't believe that current ones are really have that the kind of robustness to survive against attacks that bring a lot of resources to bear, And there might also be a lot more progress in the quantum computing space than is made public, because that would be the high value use of it, right? To exploit cryptographic systems well in advance of the technology being known. So, what you really want is something that simply cannot be taken down by someone with quantum computers, or someone that has a lot of nodes that they can spin up, people, mining capability, or what have you. You want something that's really, really solid, because this is a very important infrastructure, and also many people use payment systems, of this type as store of value. So that's the final critical aspect, is the resistance to takedown. So, well, maybe you'd want to go into some of the characteristics that are needed to achieve that.
Yeah, absolutely. So I think we can put up a high-level diagram. This is kind of like a bird's eye view of the architecture of the XX network, or at least the core architecture. And really, it's the integration of two pieces. One being a first of its kind decentralized communications platform, which we call CMIX, and the second being really the most performant blockchain consensus protocol in the world. And so while the communications platform is certainly very interesting and it enables some really cool new use cases, we're actually going to focus just on consensus and payments today for the sake of time and keeping in the subject of payments. So if we put up the 5 key approaches, we actually listed these out in our webinar, and it's in gory detail, both in the webinar and in our white paper. So I'm just going to try to give a high-level overview of these 5 approaches. But the overarching theme to keep in mind while I do this is really it's about the novel use of unmanipulatable, unpredictable randomness to choose subsets of the network to participate in consensus as an alternative to having the entire network having to participate in consensus. And we'll talk in just a moment about why that's so important. But it's good to keep in mind that this randomness that we're using can be seen sort of as an alternative to the proof of work or proof of stake systems that you might be used to, where the randomness is either chosen by a mining problem, so you win a hash race and you get to propose a block, or the randomness is influenced by how much money you have. And both these approaches can kind of be susceptible to centralization in power and wealth, which is something we definitely needed to avoid in meeting the challenges that David set out, particularly in security. So looking back at those 5 key approaches, in order to really keep the chain secure, but also to make sure that this unmanipulatable randomness is seeded in a secure way, we had to make sure that the genesis block was generated in a fair, quantum secure way. And it also, the result of it would be to generate this very strong initial random value, which would seed the randomness chain moving forward. So we call this ceremony where the initial set of nodes come together and generate this genesis block NodeCon. And again, you can learn a little bit more about that in the webinar. But once we have that secure kind of genesis block, we can use these next 3 approaches to build on that randomness seed. So the first one is something we call committed randomness. And this is where each node periodically publicly commits to a large number of secret values, say like 10,000 or even 1 million. And when that node is chosen as a BP, it reveals one of these randoms with the block that it proposes. And this random can be validated or confirmed not only by the other nodes in the network, but also by the users, so that everyone can be sure that they haven't manipulated the reveal of this random. And because the BP doesn't know or can't predict the random that came before him, if we combine these randoms, we end up with a chain of constant fresh randomness. And using this randomness, we can do our third approach here, which is endorser sampling. So we use this randomness to choose a subset of the network rather than the entire network to receive the batch of transactions and also to verify all the signatures and send in their endorsement of the block. So if you think about 1,000, even 10,000 nodes in a network, if they all have to verify and receive these transactions, and then they all have to send in endorsements, each to every other node in the network, this really starts eating up bandwidth, which is already a pretty precious resource in these blockchain networks. So by doing this, it gives us a huge advantage and lets us scale a lot better. So once we have these endorsements, we need a way to communicate them to the clients, whether they're applications or users of the network, so that they can, as David said, get that proof of finality quickly and efficiently, even on a mobile phone. Now, with post-quantum cryptography, that's actually pretty challenging because these signatures are generally very large. And so in order to accomplish this, we actually had to create a novel compact quantum secure endorsement certificate that can be generated by this random sample of endorsers and then provided to the clients of the platform. So that's how we ensure that the finality and the proof of finality is actually given to the clients in an efficient way. And then finally, we need a way to ensure that the consensus keeps moving forward in the presence of these attacks that might try to take down the network. So we've created an efficient fallback mechanism, which ensures that even when the network is under attack, whether by a nation state adversary or even nodes in the network, that it keeps operating without forks in basically any attack under BFT assumptions. So these are really the key ingredients we've used to build the next generation of layer 1 protocols. And actually, we're already well on our way to launching this out into the wild. Our beta net has actually been stable for several weeks now, and I believe it's surpassing the 3 million round mark and is actually approaching 4 million rounds at the moment. Each of these batches is being processed in just a handful of seconds. You can actually check out the dashboard, which will show you all this at dashboard.xx.network. You'll see that we have 150 nodes distributed all across the world, and they're all receiving XX coins to run our beta net.
Yeah, so that just maybe it's worth pointing out that while we have offices in our main headquarters in Cayman, we also have offices in Los Angeles and a number of people in Brazil and Thailand and so forth. So we none of those nodes are running in our offices or run by us. Those are run by they're not like other nodes that you hear about in the blockchain space. They're not being professionally hosted by services and so forth. These are being run each by a separate individual who's built a computer typically to do it with special accelerator hardware, meeting our specs and so on. And so we have over 100 that are currently live. You can see the dashboard up at xx.network. So this is and that number is growing, continues to grow. And we're paying these many of them, not all of them, with XX coins. Some of them are volunteers, and it's really exciting to see the network, coming into real life now. Sorry, Will, go ahead.
Yeah, so as you can see, this is well on its way to, we hope, provide the next generation of layer 1 protocols that all these other applications and stuff hopefully can build on one day. I want to thank Alchemy for having us here. David, did you have any closing remarks?
Also thank Alchemy, and it's been a pleasure. I'd like to share with you all something which is not yet been publicly announced, so I'll be a bit vague, but what I would like to say is that I have seen a quantum resistant consensus and payments system with our software running on like on the order of 1,000 nodes under what I believe are quite realistic conditions around the world, and I've seen a level of performance. Now, these nodes were very limited in how much computing power they could use, how much uplink and downlink bandwidth, and they didn't use the GPU acceleration, which we are using in our beta. So this is an alpha test, but I saw it with my own eyes, and it was, I saw transaction rates that were, many thousands of transactions a second. And so on a very limited, with all those limitations and everything, and a realistic setup with 1,000 nodes, I mean, that gives me a real sense that, without getting into the details, that we're able to really meet the challenge and deliver something that will give the kind of performance that the people come to expect with smartphone apps, and that will have this unprecedented, but I believe strictly necessary, and we will uniquely have it, a level of quantum resistant security against takedown, and of course protection of the payments. So with that, I'd like to thank you all for your attention, and I wish you a great rest of your conference.
Hey, my name is Jim Dolbear. I'm the Chief Marketing and Strategy Officer for the XX Network. And David, Will, and I were just talking about the question that was posed to us by the conference, which is basically what's going to happen in the crypto and blockchain space in the next year or two. And we wanted to mention three things. One is that it's pretty clear to us, and I think everyone gets this, that decentralized finance, DeFi or distributed finance, is going to grow and grow. And with putting aside the impact of sort of, disruptions like what's going on with coronavirus, disruptions to the economy that will pass. And this is because the flow of capital from investors to investment opportunities will be much more fluid and efficient. And it's our belief that that will be a very good thing, for the world, because the returns to capital will be much more broadly distributed. So in investments, in asset classes like real estate and emerging businesses, people around the world will benefit from the growth of those businesses and also from having invested in those businesses. Whereas, say, in the last 50 years, a lot of the returns for economic growth globally have benefited, say, the United States, institutional investors or VCs in the United States. So, that'll change. Second thing, and we say this, David, because of his prior relationships from electronic cash, has some information on this. He's, visited with the Swiss National Bank in Geneva, but it's widely known. I think there's, it's been published in the news really as a result, I think, of Libra kind of lighting a fire on this, Facebook's Libra. But it's clear that, governments, and particularly in the largest countries or societies, are going to introduce cryptocurrency so they have some measure of control. And we're going to see that happen. Although I would say it seems like the United States is kind of lagging behind. So that's going to happen, sometime soon. And then the third thing, in sort of our area is that we're going to see what works and doesn't work. And with respect to decentralized blockchains and decentralized cryptocurrencies, we know that Bitcoin has been a great thing, for the world, really, particularly sort of setting an example. But it doesn't reach finality quickly. There's issues of centralized groups of miners controlling it, so that's an issue. And more particularly with Ethereum. Last week Ethereum hit $60 a transaction, so you can see some of the issues with the efficiency of the underlying infrastructure. And 2 weeks ago, Ethereum Classic was hacked with a double spend problem. The people at Ethereum Foundation say that Ethereum 2.0, which is moving to some sharded version of proof of stake, will solve the problems. And there is a test net, but there are real questions as to whether that will work. And when I say work, I'm referring to what David and Will kind of emphasized in their presentation, which is speed, speed to finality, security, and the ability to scale to thousands of transactions. We're going to see in the next year or two what works and doesn't work. And I think, as Will and David said, we're trying to meet that challenge. So I hope and trust that you'll see more from us and see some real layer one infrastructure, a payment, a consensus protocol that drives payments in a way that really, really helps with the growth of DeFi and crypto generally. So thanks very much to all of you, to John Tan, and to the Global Blockchain Eco Conference.